Hi everyone, welcome to my online class, System Thinking in Engineering Mechanics, Statics. This is the first video. We will talk about the basic concept of two-dimensional vectors. And my name is Ajahn Bon from Department of Mechanical Engineering, Mahidol University. Before we go through our practice, I would like to make sure with you that in this class, I will suggest that you should use the strategy of problem solving that I call IPE, a three-step approach. The first one, you should interpret. Read the question carefully and determine that what is given and what is to be found, or what is the question asks you. And then after that, you plan. Think about the major step or maybe the sum step that you will take to solve a given problem. Maybe you can think of alternative or the creative solutions and you can choose the best one. And the last step here is the execute. You carry out your step. Use the approaches, diagrams and equations and estimate your answers. Avoid simple calculations mistakes. And that is for this class. So this is the more steps in terms of the basic concept of two-dimensional vectors. Two additionals of several vectors, we have three steps. The first one is to resolve each force into its component. And step 2 is to add all the x component together and then followed by adding all the y component together. And these two totals are x and y component of the resultant of vectors. Step 3 is to find the magnitude and the angles of resultant vectors. So let's see this question for your practice. The reference is from R.C. Hibbeler's Engineering Mechanics, Static and Dynamics. The questions ask you, there are three concurrent forces acting on a bracket. Find the magnitude and angle of the resultant force and then show the results in the sketch. So what is the question give you? The given the three forces here, and then what is their ask? They ask for the resultant force, or in this term is Fr. So this is the basic concept of vector. So we have three steps as I told you before. The first one, we find out the component of each vector in x and y axis. And then step 2, we combine the component of x and then y. And the last steps, we find out the magnitude and angles of resultant force. So let's say if we have the questions like this, so you can see in these questions they have two systems that they give you in terms of force. The first one is F1. F1 is giving you by triangles systems. So it means that for this triangle, you should set up your own angles. Let's say I will use this one as my angles. And for F2 and F3, they give you exactly the degrees angles, which is 30 degree here and 45 degree. So The basic concept of two-dimensional vector is if you have the vector f here, the components of vector you should focus on the angles, and then the component that close to your angles will be the f cosine that angle, and another component will be f sine that angle. So in this case, f1 will be transformed to the size of f1 sine theta plus the size of f1 cos theta. And don't forget to put I and j here, and don't forget to check the size. For this one it is plus, and this one is minus. We will continue with put the numbers in here. So we will get f1 is equal to 850, sine theta is 4/5 I, and then minus 850 here, cos theta is 3/5 j. In this step, you can use your calculators to find out the final number of this one. So 850 multiplied with 4/5 will be equal to 680i. And then another terms, 850 multiplied with 3/5 will be 510. We are in the first step and it's not finished yet because you should have f2. f2 in this case will be minus 625 sine 30, and then again minus 625 cos 30 I and j. f3 will be minus 750 sine 45 I, and then plus 750 cos 45 j. I need more space, so I will delete all of these concepts. So after that, after we got all of the components in terms of x and y in each forces, we should continue to combine it together. So our FR will be the term of 680 minus 625 sine 30, and then this term minus 750 sine 45, and all of this is in the x-axis or I vectors. And then we have minus 510 minus 625 cos 30 degrees, and then plus 750 cos 45 j. Don't forget that this is step number 1 and this is step number 2. After this, use your calculator properly to find out the number in the cycle. So the first term should be minus 162.83 I. Please use your calculators to continue with me. In that case, you have to practice how to use your calculations. And then another terms will be minus 520.94J. And this is our resultant force in terms of the vectors. So in the last steps, step number 3. So after we go to the second step, we can find out the resultant force in terms of vector I and vector J here. So we go to the last steps. It is the steps. So in the step, you should be able to draw out our resultant force like this. So it is minus 162.83 in terms of x, and then minus 520.94 in vector j. So the overall resultant vector should be somewhere here, which has the size equal to square root of minus 162.80 square plus minus 520.94 square. So use your calculator again. You should get the size of resultant vectors as 545.7949 something, and according to the significant figures, the answer should be 546 newtons. And then we should find out some vector that we will use the tan theta equal to minus 520.94 over minus 622 x to 3, which you can find out that this theta is 72.64 degrees. So you can use this number to answer as it is from the negative x-axis. or you can put it together with these angles to answer the question in terms of the positive x-axis. So we pass itself as 180. You will get the angle is 252.64 degree from the x-axis. So that is all of the step to the two-dimensional vectors. So in terms of the conclusions to the vectors, don't forget that we will start that IPE. What is given and what is the questions asked you, and then you go to the steps, which that they have 3 steps in this. The first one is find the component of each force or vector that they give you, and then in terms of x and y, and then combine components of x-axis and then components of y-axis, which you should get the resultant force. And the last step is find out the magnitude, find out the magnitude of resultant force, and then the theta that normally we use the theta that act on the x-axis. And then for the step 3 of the IPE, you just do it. And that is for the two-dimensional vector. Thank you very much. See you next videos.